Hello guys, welcome to Cisco with Mansoni, and in this video we are going to talk about our friendly EIGRP. So this is actually a second video of the series. So in the first EIGRP series we talked about basics of EIGRP, the most fundamental things, how to make neighborship, how they exchange routes, how they create the topology, and all these basic stuff. But there are some important terms that we need to discuss, like we'll be doing it today in this scenario I have created for you. Let's imagine we have a R1, R2, R3 connected with each other and EIGRP is already running on them. So EIGRP is already configured and they will be exchanging some routes. Let's make it a little more space for us. Okay, and imagine we have a destination network running here. Let's take whatever you like, 10.110/24, whatever network, I'm just picking randomly. So I have a network here. Now guys, EIGRP is already running behind the scenes. And this router R3, our Kakashi router, so this router will be telling this route with R2. It will be sharing that route to R2 because EIGRP works on routing by rumor concept. Meaning what? When you start EIGRP, I will be making the EIGRP neighborship with my other guy, and after making the neighborship I will exchange the routes. So when I exchange the routes, let's imagine the distance calculated by EIGRP is 5. In reality the distance will be much larger. It can be 5,000, 10,000, 350,000, like that. But let's assume here is just some simple numbers to keep things simple. So let's imagine the distance of the destination network from our R3 is 5. So now how it will work when the route of, let's advertise the route here, when the route of 10.110 is advertised to the R2 from R3, then R3 will say that this is the route, the information of the route I want to exchange with you because we are EIGRP neighbors, and the advertised distance for the destination network is 5. So now what this R2 will do, it will immediately process that information and that route entry will be stored in the topology table. And in the topology table as well, I will put that I just learned a new route 10.110/24 from my neighbor R3, and the advertised distance of that destination, the advertised distance to reach that network told to me by my neighbor is 5. But keep that in mind that R2 is also far away from R3, and the distance between these two routers, let's assume in this case, is 10, depending on the link, depending on the bandwidth and the delay. Because EIGRP, to calculate this distance, use two parameters, bandwidth and delay, using a formula that we discussed in lecture 1 of EIGRP. Now to our Hitachi router, what it will do, it will say that yes, I got the information that my destination network 10.110 is 5 distance away from my neighbor, because he told me like this. But I also know that I'm 10 distance far away from Kakashi. So what I'm going to do, I'm going to take that distance and I'm going to add that distance to the distance provided to me, and I will calculate the total distance. So this also gives us the definition of what is a feasible distance. So guys, what is a feasible distance? It is nothing special but the total distance from the source to the destination, and it is calculated using the AD value, the advertised distance provided by my neighbor. In this case, pretty straightforward. My neighbor did what? My neighbor just told me that this destination network is 5 distance away from me. Just a minute. So this is the definition of the feasible distance. Whatever distance provided to me by my neighbor friend, I will take that and I will calculate the distance that I already know, how far I am from my neighbor. So it is simple math. What Itachi will do, he will say I received a route from my neighbor. He is saying the advertised distance is 5. It means that network is 5 distance away from my neighbor. but from me it will be simple math. 10 plus 5 he will do. He will say that the total distance towards the destination 10110 is 15 for me. So that total distance, EIGRP just has a fancy name of calling that total distance a feasible distance. So Itachi will store that I know a destination network of 10.1.1.0 and the advertised distance to reach to the network is 5, meaning what? My neighbor told me that the network is 5 distance away from him, which is right here. But from me, the total distance towards the destination network is 15, which is known as the feasible distance. Now, it happened to be that Itachi has another EIGRP neighbor, our Naruto R1 here. So he will again, the same process will be repeated again. He will say, Naruto, I know a network which is 10.1.1.0, and for me, the distance is 15. He will say, if you want to go to the destination network, the distance from myself is actually 15. So I'm advertising the distance to you. If you want to happen to be go there, you can go via me. The distance is 15 from me. Keep that in mind. But Naruto will say, okay, cool, I just got a wonderful route. But my neighbor says it is 15 distance away from him. So for Naruto, the advertised distance became 15. And now Naruto will do the simple math. He will say it is 15 a distance away from my neighbor, and I am 5 distance away from my neighbor as well. So what I will do, I will just do the simple math, I will add them, and I will say the total distance from Naruto to destination will be 15 plus 5, that is 20. So I think I happen to have the slide here somewhere. Okay, just give me a sec. This is the slide I have here. So Naruto will say that I received the advertised distance of 15, and I will add to the math, the total distance is 5. So in simple words, in plain English, what is advertised distance? How far is the destination from my neighbor? And what is feasible distance? It is just the total distance from myself to the destination. And how I will calculate that, my neighbor will tell me the advertised distance, and I will simply add up the distance from me or myself to my neighbor, and voila, I have the total distance in front of me. And it was just like normal fact I want to share with you. You can explain, or you can say it in another words, that what is FD? What is advertised distance? The advertised distance of my okay, the feasible distance actually. Whatever the feasible distance, or I'll just write FD, the feasible distance of my neighbor is my advertised distance. Meaning what? Take a look here. Itachi says that my feasible distance is 15 to reach the destination. And if I'm Naruto, then whatever feasible distance of my neighbor, that will become my advertised distance. That's how the concept of this EIGRP distance calculation works. Itachi will say the neighbor, the destination network is 15 distance away from me. That is the total distance, and that total distance I will advertise as advertised distance to my friends so that they can reach. And if we happen to have some other routers behind Naruto as well, then the same thing is going to be repeated again and again and again. The main thing, the concept I want you to remember, that what do you mean by advertised distance and feasible distance? Because when we are going to jump in the EIGRP practical, we are going to throw in 3-4 routers, and we're going to create a very good scenario. And in that scenario, I will go into the topology table, and I will show you how in reality this advertised distance and the feasible distance looks like. So depending on these things, what is my AD value, I happen to have received 2 routes from 2 different directions, and both will be telling me some other advertised distance. One guy is telling me 3000 AD, another guy is telling me 4000 AD value. So whichever distance is obviously smaller, I will believe that. If someone is telling me the AD of 3000, I will take over 4000, and I will use that path, and using that AD I will calculate my total feasible distance. So let's jump onto GNS and let's do a very good practical of EIGRP. So it is not going to be a very basic practical. If you want to, you actually not want to, you should have watched the EIGRP lecture 1 completely. You have to be thorough with it in order to completely understand whatever we are talking right now. So in this practical, I'm going to do some very cool manipulations. Meaning what? Let's take 4 instead of 3 routers, and I'm going to create a dummy network right here on our R3, and I'm going to put F00, F00, or let's do one thing. Let's connect F00 here, and let's connect F00 here as well. Let's connect. Now guys, look here, let me show you the interface. We have fast Ethernet everywhere, and we have this route right here. Now if on the last remaining link as well, if I connect the fast Ethernet here, now from both of these paths the distance is going to be same. Meaning what? I will be having 2 paths from R1 to the destination, one via something like this link, like this. I have 2 paths, 2 fast Ethernet link here and 2 fast Ethernet link here. I don't want that. I want to make one path better, and I want to see how it works. So I will, instead of fast Ethernet, I will put an Ethernet cable here. Let's start the topology. And we will just throw in some IP addresses, some basic ones. Let me turn off some unnecessary stuff which might cause high CPU. Close this. Okay, looks good. So I think I can even hear the CPU fan roaring up. I think all our devices are up and running. Let's take CLI first of all. We have the CLI of R1 here. And yes, yeah, guys, sometimes students ask me, they also put in comments and in chat and WhatsApp that which CLI tool I'm using. It's not putty because it looks much better, it is transparent, and we have tabs in it. So yes, it is not putty, guys, it is actually secure CRT. So you have to install it, you have to set it up separately, and you have to bind that into GNS. I have a separate video for that. I'll do one thing, I'll put that in the description as well, or you can just go to the channel and you can say, you can look up how to install secure CRT. There will be a video on that from the channel. So first thing first, we have to have some basic IP addressing everywhere. So here we have 12, let's take 12 network, the network for 23, the network 14, the network 34110, and in here let's take our same old 192.168.1.0/24, and IP for the PC, let's take .10. Okay, so we are good to go, I guess, and let's take seal. I'll do one thing. For example, we have R1, so all the IPs I'm going to put will be .1, meaning what? We are going to have 12.1.1 here, 14.1.1.1 here. In here, 12.1.1.2, 23.1.1.2, 14.1.1.4, 34.1.1.4, 23.1.1.3, and here 34.1.1.3, and in here I'll put 192.168.1.3 as well. So it will be easy for you to understand and remember as well. IP address 14.1.1.1 because it is our router 1. Using the router and router number as the IP number. Simple thing. Interface, bear in mind we are using Ethernet here, which is 10 Mbps, guys. EF1, IP address 12.1.1.1.255.255.255.0. No shit. We only have two IP addresses, both are configured. EIGRP, guys, we are going to configure. Okay, let's do one thing. Let's do EIGRP right now. How to configure EIGRP? Quite easy if you have watched the lecture number 1. If not, or if you don't remember, go back and watch the video. So router EIGRP 100, my AS number. I have two interface, so I will turn on EIGRP on both of them. Network 12 and network 14 I'm using here. So my EIGRP is up and running. Hello messages will be going out, but on the other side they will be just listening and waiting for EIGRP to initialize, because on other side no EIGRP. Let's jump to R2. We have interface EF0, IP address 12.112.255.255.255.0, no shut, interface F10, IP address 23.111.255.255.255. Okay, slow down. Okay. Wait. My bad. I gave wrong IP, interface E50. Good thing if you give wrong IP, just go in there and again give the IP address. It will override the old one. So 12.112, perfectly right. Turn it on. Interface F10, IP address 23.112. Why? Because we are on R2. That's why, my friends, we are giving .2 and .2 here as well, because we are on R2 to keep things simple. IP address is done, and side by side let's do router EIGRP 100. One other thing, on R1 we are using router EIGRP 100, so we should use router EIGRP 100 everywhere. Otherwise they will be in different AS number, and when they will send hello message, in the hello they will say the AS number is 100, mine is 200. I will not form neighborship or friendship with this guy, and they will never become neighbors, and they will never exchange routes. So router EIGRP 100 network, I have 12 running here, and on the other side I have 23 running here. So this side, as you can see, we turn on here and here, hello message send, neighborship came up, and this is the message for the neighborship. Let's hop on to R3. Router EIGRP 100, but okay. First, let's give IP address. Yes, if you do EIGRP first and then afterwards you do IP address assignment, it will also work. But I think it is better if you assign the IP addresses first. IP address 23.113, because we are on R3. Interface F00, we have the network 34.113. No shut, we are good to go. One left, that is going towards my PC, 192.168.1.3. You might be wondering why I am not writing the IP addresses here, because I want you guys to remember it. Yes, later on we might have 8 routers, 10 routers, 20 routers. So try to remember in this like simple cases, try to remember the IP address. If they are complex, they are different, so 75.89.198, different weird IPs, then you need to write it down. This is simple case, we are creating it, we know the IP address. For example, on R4 I know it is 14.114 here and 34.114 here. That's why no need to write the exact IP addresses for each and every interface. So for R3, IP addresses are done. If you want to check, do show IP interface brief. These are the IP addresses. Okay, everything good. Look, it even looks good. 333 on R3. Okay, rhymes well as well. So let's do router EIGRP 100. Let's do the network command. We will be using 3 network commands. Why? Because I want to turn on EIGRP on 3 interfaces. 34.0.0.0, 192.168.3.0. Do not forget to turn on EIGRP on this guy right here, because if you don't do, what will happen? Two things will happen if you don't do this. First thing, it will not send the hello packet out to the PC. Now you might say, if it is not sending the hello packets toward the PC, why would I need that? Yes, true, we don't even need it to send the hello packets. Even if it is sending hello packets toward the PC will not recognize it. But another bad thing will happen if you don't give this command. If you don't give this command, EIGRP will be not turned on the interface, and it will not be advertised to other neighbors as well. Meaning what? This guy R2 will never hear about this network. This guy will never get to know about this network. When you turn on the protocol EIGRP or OSPF on the interface, it will start sending hello messages out to form the neighborship. And also the network running on the interface will be advertised to my other EIGRP or OSPF neighbor as well. That's why we need to do that. And the very good command, you can check if EIGRP is properly enabled on all of my interfaces or not. Show IP EIGRP interface. That's it. I have two interface. It is enabled on two interface 2334. It should be three interfaces. Show run section router. This is a handy command to see all your EIGRP information. Okay, something wrong. I gave 192.168.3.0. I don't have that network. I have 192.168.1.0. That's why this command is so handy. Config T. Okay, so we missed one command. Instead of 192.168.1.0, which is running right here, this network, we gave 3.0. So what now? Do I have to turn off my whole EIGRP? Or I have to just go in EIGRP and I can rectify my mistake? You can do both. But imagine you have a lot of EIGRP things going on here. So it doesn't make any sense to turn off EIGRP. So what you will do, router EIGRP 100, network 192.168.3.0. We gave this command which was wrong. We should have given 192.168.1.0, but by mistake we wrote 3.0. So go in the beginning and just put a no in front of it, and this command will be gone. Then give the right command. Be careful with that. Okay, so that's how you rectify a mistake. If you have given any wrong command in EIGRP and also in OSPF, it will work the same. Whatever command you gave wrong, write down the exact command, put a no in front of it, it will be gone, and rectify your command. Exit, show, run. Let's simply check whether EIGRP is turned on or not on all of my three interfaces. Show IP EIGRP interfaces. Yes, nonetheless, all three are working fine. So let's hop on to our last router. Interface F00, IP address 34.1.4.255.255.255.0, no shutdown. Interface F10, IP address 14.1.4.255.255.255.0. Only two interface, and let's turn on EIGRP. I have network running for 14. I want EIGRP to run for 34 as well. My neighborship message coming up. Everything seems to be running smooth. Show IP EIGRP interface. Yes, it is running on both of my interfaces. And how many neighbors I have? The neighbor will be shown in the neighbor table. Pretty simple. Show IP EIGRP neighbor. Guys, try to remember this command. Show IP EIGRP for EIGRP. Why? Because you can do show IP EIGRP interface. You can do show IP EIGRP neighbors. You can do show IP EIGRP topology. So it's a pretty handy thing to remember instead of remembering 3 or 4 commands. Show IP EIGRP neighbors. How many neighbors I have? I have 2 neighbors working fine in EIGRP. One is 14.1.1.1, this guy. Another one is 34.1.1.3, this guy. Let's hop on to R1. How many neighbors my friend R1 has? Show IP EIGRP neighbors. I have 2 neighbors. Now my friends, same story that we studied will be happening here. This route will be coming from top side and from the bottom side as well, but we know that bottom side is better, it is faster, and that's why it has least or simply less distance than the top route, top path we can say. Why? Because we knowingly put fast Ethernet here, 100 Mbps link. and 10 Mbps Ethernet link over here. So R1 will receive two routes. I told you do step by step. First thing, I will make neighborship with my two neighbors. They will be telling me routes. Whatever routes they will be telling me will go in the topology table. That's the rule if you remember from lecture number 1 of EIGRP. I will make neighborship by checking the hello parameters, everything fine. I have two friends, EIGRP neighbors. Now, whatever routes are told to me by my neighbors, I will put them in the topology table. So let's see, for 192.168.1.0, I have indeed two routes. One is coming from fast Ethernet 00 on my fast Ethernet 00 actually in here. It is coming on my fast 00. I'm learning it here. And I'm learning it on Ethernet 5.1, my 5.1 interface, this interface right here. Now, if you look carefully, it is telling some distance, like bigger numbers. So how to read these numbers, my friend? Whatever number in the topology table you will see, the first one is your feasible distance and this one is your advertised distance. So what happened from here, on F00, the AD told to me by R4. R4 told this guy that if you want to go to the destination, the advertised distance is this, which is 30720. This is the distance from me. R1 will listen to it and it will add its own distance and it will calculate the total distance from R1 to the destination network, which is 33280. This is the total distance from here. So how it works, I will say this one is from top side. Let's take a look here. I'm learning the route on EF1, which is here. This guy is also, R2 is also telling the AD, which is 30720 as well. Because if you take a look, this path and this path is identical. That's why from both sides, the AD value is coming same. We have same link, same bandwidth, same delay. But the picture completely changes when my R1 is calculating the total feasible distance. Because in here I have a 10 Mbps link, meaning what? My bandwidth is very less. That's why my distance will be very large. It is inversely proportional, meaning what? Your bandwidth will decrease, then your distance will increase. It simply said, I don't like larger distance. Larger distance means less speed. It's like that. So from top side, from on Ethernet link, my feasible distance after the calculation comes 286,720, which is, my friends, very larger than the 33280 value coming from the fast Ethernet link. Okay, that's why what will happen, I have to choose between these two routes. I will choose the best route and then only the best route will go in the routing table. So which one is the best route? Obviously, which is giving you the least feasible distance and the best path. There is a name for that, and that best path is called successor. So just look here. If I want to reach to 192.168.1.0, I have only one best path or one successor, and the distance of that successor, the feasible distance, the total distance from the best path is 33280. And which is that path, obviously, which is coming from the fast Ethernet. So I will take this first entry, this first route, and I will copy that in the routing table. If I want to go to 192.168.1.0, I will go via the 14.114 link, which is connected to my F00, and this is the feasible distance, total distance that you saw in the topology table as well, written right here. That's the rule of the successor. So today we learned about successor. We learned about advertised distance, the distance of the destination towards for my neighbor, and we learned about feasible distance, the total distance from myself to the destination. Almost we are done for the day, but there is one thing left. which is known as the cousin brother or little brother of my successor. This guy. Successor means best path, my friends. And there is the little brother of successor, which is known as feasible successor. And that feasible successor you can also call the backup path or the second best path. So let me put a note for you guys. What is feasible successor? It is the best path to reach to the destination. Okay, that's actually successor. That is the best. Okay, and let's talk about feasible successor. Just think it is the second best path to reach the destination, the little brother, you can say. So what is the condition for successor? Least FD value. Simple as that. The route, the path giving me the least FD value will become the best path. So for the successor, the second best path to reach to the destination. What is the condition for that? The condition for that is little more complex than the successor. The condition for the feasible successor is, my friends, that the AD value should be less than the FD value of the successor. Yes, I know it sounds weird and might be confusing as well, but you have to remember this. And for you guys, I'm going to show you right here how it really implements and looks like. So for that, let's go to the topology table. It simply says when the feasible successor will come, it will tell you a AD value, an advertised value. You have to compare that advertised value to the feasible distance of the best path. That's it. Meaning what? This is my another path which is not successor. So he is telling me an AD value. This AD value you have to simply compare with the best value, the feasible distance of the best path, the total distance, the best FD of the destination network. So if that AD value is less than the FD value of the successor, then this route right here is eligible to become the second best or the feasible successor. And as you can see clearly here, this condition is being met. This value is less than this FD value. That's why, my friend, this route is also the feasible successor or the second best path. And EIGRP is the only routing protocol which keep track of the second best path. Meaning what? If something goes wrong to this path, maybe the interface goes down, the cable goes down, and this route disappeared from the routing table, then immediately the second best or the backup path route will be installed immediately in the routing table. Neither RIP nor EIGR nor OSPF can do this thing. They have to again recalculate or ask their neighbor. But EIGRP keep track of a backup path, that's why it's also very fast. So you might say this path is feasible successor, but where it is written? It is not written anywhere. So my friends, it is already understood, because if another path is there other than the successor in the topology table, then it is understood that that second path is the feasible successor. So let me just summarize that. What is there in the topology table? So we have the best path and the second best path. If the condition fails to become the backup, the route will not even show in the topology table. And if it is not showing in the topology table, then it is not your successor. But my friends, still if you want to see that where it is written, so there is another table, or the full table I can say, show IP EIGRP topology all links. In this table you will see that path. This is the table. If it is not here, it means it failed the condition, then it should be here somewhere. Right now in our case it will be same, because it will be in both places. So that's how EIGRP works and the basic important terms of EIGRP. So please do this practical the same way, and I would recommend do this while you're watching the video. Watch the config, pause the video and do it in GNS3. If you have any doubts, you can mail to me, you can write in comments, and I will try my best to get back to you as soon as possible. And I will really appreciate if your likes and feedback and for comments, whether good or bad, if you want to improve anything or if you want anything new from my side. So that's it for the day, guys. Hope to see you again in the next video. I'm signing out for today. Bye. Have a good day to all of you.